Hello and welcome to Basins and Beer with ESA Analytics. I'm Blue Spikes. Today I'm going to be talking about the Williston Basin in North Dakota and Montana, and I'll be drinking an isolation ale by Odell Brewing. This is what the can looks like. It's kind of a pretty scene on it, if I can get it positioned just right. It's a 6% beer with an IBU of 29. The last Odell beer I tried was Easy Street Wheat, and it was my favorite so far, so I'm looking forward to trying this one. That's okay. It's not nearly as smooth. It does taste more of the caramel malty ale that I think they were going for, so I do like it. Not as much as Easy Street Wheat, but it'll work for the rest of this episode. So let's get into the application and start talking about the Williston Basin. So first thing you want to do is always load up the region you're interested in. In this case, we're going to scroll down to the very bottom. It's the Williston. So hit apply. Williston's not quite as big as some of the other basins we've looked at in terms of well count, so it loads pretty fast. I always recommend loading by formation first, just to get the lay of the land and just get a sense of what everybody is targeting here. So this is your map showing the outline. Let's just turn on the regions in general just to give you a sense of, okay, so this is North Dakota, this is Montana over here, so you can just get a sense of exactly where this basin's located. If we turn off the dots, I can give you a sense of the towns that were sort of, so Bismarck and Minot, those are the towns that are, covered up by the basin when I turn on the dots here. And then if we open the sidebar, we can see what formations are most common. It's probably no surprise it's going to be the Bakken. Anybody who's paid any attention to what's going on in North Dakota for the last 20 years knows that the Bakken is the big play there. And sure enough, there are more Bakken wells than any other. There are some Madison wells. That's a common target. Those were the verticals up in the northeast. So the Bakken has a few different benches. There's the Bakken Middle, which is the most common, but there's also the Bakken and then the lower Bakken. Three Forks is another common target. That's sort of the main targets for horizontal wells in the Williston anyway. One thing I want to show you is how things have changed over time. So I like to load this up based on vintage. This basin hasn't been around quite as long as some of the others as far as like when the drilling started. Let me find the producing length, and then I'm going to change this color by to direction. So what's kind of cool about this is it shows the core of the basin is the red, where you have all the horizontal wells. And if we just reset this, you can see that if you combine the horizontal wells and the horizontal multi-wells, so the multi-wells are ones where there is more than one horizontal well coming off of one, what they call a mother bore, but they're all horizontals. There are more horizontals than verticals, and that's pretty unusual for a play in North America. And if you look up here, you can also see the wells didn't get started in North Dakota until the 30s. A lot of these basins, Powder River, DJ, parts of Texas, they were drilling late 1800s, certainly early 1900s. So this basin got a little bit of a late start, but once it took off, it really took off with these horizontals. So that was what was really necessary for this basin to be economically feasible. This is just an interesting look at how things really ramped up in terms of overall drilling in the Williston, and that's pretty unique to this basin. Another thing that's probably of interest to a lot of people is if we just look at operator. So this will just give you a sense of like where the different operators are drilling and who the biggest players are up here. So the funny thing about the operators, there are so many of them, you really have to drill in to this chart to see anything. But so Continental, Hess, Whiting, Danbury, those are your really big players. ExxonMobil's up here. Petro Hunt and Enerplus are big players, EOG is another big player up here. And you can just see by the coloring, if you really wanted to figure out where someone's acreage position is, this is how you would do it. You color by it, and you could filter down. Let me get rid of the part that's showing my head here, and I can show you how you can filter down. So you can choose which operator you want, and you can do the same thing with the formation, same thing with direction, and all these different filters. It just allows you to drill down quickly to whatever information you're trying to evaluate. Let me point out one other thing that's kind of cool. We now have stock prices that are updated, and oil and gas prices along the bottom, as well as rig counts from Baker Hughes. If I turn off the dots, I can show you what this Baker Hughes layer looks like. It's this drilling rig. And so what this is showing is every county in the U.S. where there is currently a drilling rig operating. And so they're color coded. So, you know, the darker the color, the darker the blue, the fewer the rigs. The red would be your highest number of rigs. So in southeast New Mexico here, this is all Permian Basin. But looking up here at North Dakota, this is what your drilling activity looks like. So in Dunn County, you have 12 rigs. Williams County, you have 5 rigs. Divide County, you have 3 rigs. And over here in Roosevelt, in Montana, you have 1 rig. So anyway, that's kind of a cool thing. Oh, and there's another one here. This is McKinsey. They have 10 rigs. So this just gives you a sense of what the current activity looks like. It's still a very active basin. And just showing these different numbers along the bottom, it allows you to sort of stay in the app and focus on what you're doing, but also keep track of these key metrics that affect your industry. So kind of jumping back to Williston specifically, one thing that's always of interest is if you look at structure. So let's drill down here. We know that Bakken Middle is the most common target. So let's drill in and look at what structure looks like. So turn off our rigs, turn on our dots, and now we know this is the structure. So the middle of the basin here is, and this is actually the deepest part, which corresponds to part of what we'll learn is the core acreage, but really the core acreage is kind of in this area. And so it's interesting that it's not necessarily the deepest part that is the best part of the basin, which is, again, a little bit unusual and specific to this basin. Another thing you can do if you want to aggregate by formation, you can, let's pick formation depths. You can pick the same thing, Bakken Middle. Bending size, I usually set it at 2. So what this allows you to do is I can turn off the dots, turn on the bends, and now I see an aggregated layer of those same depths. And the reason why you might want that is, let's say you wanted to plot temperature along with depth. So we'll choose temperature, apply that, turn your dots back on, and now you have a background layer of depth with your dots, which are now colored by temperature. So this just gives you the ability to map 2 things at once, and that often reveals patterns that are essential to understand. So I think the next thing I really want to get into is the idea that with this kind of app, you can start to really look at tiering off acreage in terms of what's your tier 1 acreage, your tier 2, tier 3. We haven't built in a reservoir model yet, so that you could look at just the rock quality or what are the real properties of the rock and the reservoir quality based purely on geology or engineering. But we do have production data, and that's often used as an analog for reservoir quality, or at least what you can expect to get out just based on what other companies have gotten out of it. So if I plot oil 1 year, and in this case I'm going to change my binning to also be oil 1 year. We don't need that yet, but I know we'll need it in a minute. So if we just look at oil 1 year and turn off our bins, this already reveals where the core acreage is. So you can see just based on the colors over here. So let's so the blue would be your lower oil 1 year values. Your greens and yellows and reds would be your higher values. So this is your best acreage based on production. Again, because this isn't a reservoir model, it doesn't tell you exactly what's going on with the rocks. It just tells you what the other people who've already drilled wells are getting as a result. So it's an analog. And I think it's probably the most common way to evaluate acreage because it's readily available and it requires the least amount of expertise. So I'm going to walk you through sort of how I would do this, at least with this type of data. So we've already got it boiled down to the wells we want to look at because we're in the Williston Basin, and we know that the formation we're interested in is the Bakken Middle, because that's what most people are focused on. So let's just go right to what everybody else thinks is the best rock and assume that that's going to be the best for us as well. Now, of course, if you had more time, you would evaluate other formations, but for the purposes of this example, we just want to get to what we know will give a good result. We also want to filter down to horizontal wells because that's most likely what we're going to want to drill. Okay, so we already have a map here of horizontal wells targeting the Bakken, the middle Bakken. So I'm going to pull up the table and show you. So with oil 1 year, scroll over here till I find it. I think there it is. Okay, so I can use this to filter down to a specific minimum for oil 1 year, because my idea is that if you can figure out which areas will allow you to recover your initial investment within 1 year, that to me is tier 1 acreage. Again, purely based on this production analog. It may not be the same as the tier 1 acreage that you would get with a reservoir model, but it does, I guess, in my eyes, tell you from an economics point of view, where should you be drilling? And I would like to normalize by foot, because if I do that, it doesn't matter if I'm comparing to a well that was a 1 mile lateral or a 2 mile or a 3 mile lateral. I can do apples to apples with any length of well. So now I've normalized all of my oil data by my oil 1 year data by length, so I've got oil per foot now. And really all I need is to know, well, what's my threshold? What is my oil per foot number, my magic number, where if I can produce more than this number, I will make my money back in 1 year. And so I'm going to show you, and I have numbers that I could dig up, but I went ahead and used ChatGPT for this because it can give me numbers for the entire country based on published numbers, and it sort of compiles it all together. So this is what ChatGPT says it's going to cost you to drill a well in North Dakota. And so it says a 2 mile lateral is going to cost you $9 million. That's drilling and completions. You're going to have an LOE of $7 a barrel, transportation and marketing, another $3, water disposal, $4 a barrel, royalties 20%, taxes 10%, capital expenditures 1.2 million, so things like gathering systems, and then you have a discount rate, sort of the time value of money. So using these numbers, which everybody out there is going to have a different opinion, different operators can operate on different scales. You might have a multi-pad well that can drive down this capital expenditures. You might have some drilling efficiencies that drive this cost down. But this is currently, according to ChatGPT, the current cost or the average cost over the last decade to drill a 2-mile lateral. So using these numbers, I come up with 23 barrels per foot. That's what I need. In my first year, if I can generate 23 barrels per foot, I will make my money back in 1 year. So if I set that threshold in the filter and I say filter by table, this shows me the area in the Williston Basin where I can supposedly make my money back within 1 year. Again, based on those principles or based on those economic variables. But the interesting thing is, if you happen to have a published map of, tier 1 acreage, this closely matches that. And that's just, I think, proof that you can use this to arrive at the same conclusions that a lot of other people are deriving. I'm not going to tell you that you should ignore the reservoir properties, because I don't think you should. I think you should look at reservoir properties. Look at the actual geology, because you might find that this isn't the only area. You might find some sweet spots that this is missing. And that's, of course, where you probably have some leasable acreage, and so it might be more important. But if you're just looking for a quick, easy way to evaluate acreage, this tool gives you a way to do that. And because it has all the well data in here, it really is very robust. It's quick, it's easy, and I think anybody can use it. So that's probably enough for tonight. Until next time, cheers.